In this video, I'll be talking about nuclear instrumentation systems, specifically X-core and in-core nuclear instrumentation systems. These systems plays a vital role in monitoring and controlling the reactor performance, ensuring safety and efficiency. I'll briefly explain the key differences between these systems and why these systems are essential in a nuclear power plant. X-core instrumentation systems are the instrumentation systems or the neutron detectors that are located outside the reactor vessel. These instrumentation systems detect the leakage neutrons, the neutrons that leaks out of the reactor vessel. The leakage is directly proportional to the power inside the reactor vessel. Now that we have a basic understanding of the X-core instrumentation system, let's take a look at the four major purposes of the X-core instrumentation systems. The first one is to provide indication of reactor power from shutdown to full power conditions. Second one is to provide input to the reactor protection system during startup and power operation. Provide reactor power information to the automatic load control system. The fourth and final one is provide axial and radial power distribution information during the power operations. As I said earlier, the reactor power level is measured by detecting the leakage neutrons from the reactor vessel. There are reasons for this. The first reason is the reactor power level is directly proportional to the leakage neutrons. The second one is it is easier to operate and maintain a detector which do not operate inside the reactor vessel, which is a very hostile environment. The X-core instrumentation system comprises of three subsystems: source range detectors, intermediate range detectors, and the power range detectors. These detectors are gas-filled detectors. When an ionizing radiation enters these gas-filled detectors, it will ionize. As a result of this, positively charged ions and electrons will be produced. These electrons will move towards the center, which is positive, and these positively charged ions will move towards the cylinder, which is positive. This movement will create an electric current. This electric current is detected by the electronic circuits. That's how it is measured. There are two types of radiations entering the gas field detectors: the gamma radiations and the neutrons. The gamma radiations directly ionizes the gas inside it, but the neutrons, they are not ionizing. So in order to detect the neutrons, we need a target nucleus, which is boron inside the gas. When the neutrons interact with the boron, it will produce lithium and helium and then electrons. This lithium and helium, they are positively charged ions that will accelerate towards the metal cylinder, which is negative, and the electrons will move towards the center, which is positive. This will create an electric current. So electronic circuit will detect this current. I will explain briefly about the source range detector. The source range detector measures the lower power range. So the detector used here is boron trifluoride detector. In this range, the electronics see the pulses caused by both neutrons and the gamma radiations. But at the lower power range, the reactor power is not directly proportional to gamma radiation. So we have to exclude the pulses created by the gamma radiations. So here we use a process called pulse height discriminations. So this will exclude the pulses caused by the gamma radiations. Let me tell you how this happens, because the pulses caused by the gamma radiations are lower, but the pulses caused by the neutron are higher. So this pulse height discriminator will exclude the pulses caused by the gamma radiations, leaving only the pulses caused by the neutron. The next is intermediate range detectors. It overlaps with higher decades of the source range and fully overlaps the power range. The intermediate range uses a detector called compensated ion chamber. They are nothing but two concentric cylinders. The outer cylinder is lined with boron, so it will detect the neutrons. The inner cylinder has no boron. The next is the power range. This is the highest range detectors. Except for the startup and shutdown, the reactor operates on the power range. They uses uncompensated power chamber. At higher power ranges, the reactor power is directly proportional to the gamma radiations. So the gamma compensation is not required. The purpose of the in-core instrumentation system is to provide a detailed information about the neutron flux distribution, both axial and radial distribution of the neutron flux inside the reactor vessel. Also, fuel assembly outlet temperature at various locations inside the reactor vessel. The in-core instrumentation system includes movable in-core neutron flux monitoring system and the in-core temperature monitoring system. Then there is aeroball measurement system. These aeroballs are steel balls containing vanadium. The nitrogen gas driving medium transports this aeroball inside the reactor pressure vessel. Then these balls are retrieved. Inside the reactor core, these balls will get irradiated. After radiation, these balls are retrieved and they are analyzed for the flux map distribution inside the reactor core. So in this video, I have given a brief explanation about the nuclear instrumentation system, how it works and what its significance in the nuclear power generation. Thanks for watching.